Welcome to Math Tutorials. In this video, we are solving every question of exercise 7.10 of Chapter 7, Integrals, from the NCERT Mathematics textbook for Class 12, Part 2. Exercise 7.10 wields the properties of definite integrals. 21 questions where reflections, parity, and interval splits evaluate integrals that direct methods cannot touch, including the famous log of 1 plus tangent. Here is the list, grouped. Question 1. Cosine squared, but now by the reflection property rather than identities. Swapping x for pi over 2 minus x turns cosine into sine. By the property, I also equals the sine squared integral. Adding the two forms gives the integral of 1. So I is pi over 4. Question 2. The famous king property template. The reflection swaps sine and cosine in the fraction. Adding I and its reflected form makes the fraction collapse to 1. Half of pi over 2. Question 3. The same template with 3 halves powers. The exponent is irrelevant to the trick. Reflect and add. The fraction sums to 1 again. Pi over 4. Question 4. Fifth powers, cosine on top this time. Identical engine. Reflection swaps the roles. The sum of the two forms integrates 1. Pi over 4 once more. Question 5. A modulus. Split the interval at the corner -2. Negative branch left, positive branch right. Split and integrate each branch. 29. Question 6. The corner sits at 5, splitting 2 to 8 symmetrically. Two triangles of equal area. Split at 5. 9. Question 7. Reflect x to 1 minus x to untangle the power. The reflected integrand is a plane difference of powers. By the property, the integral equals that of 1 minus x times x to the n. Two power integrals combine over a common denominator. Question 8. One of the most beautiful results in the chapter. Reflect x to pi over 4 minus x inside the log. The tangent subtraction formula turns 1 plus tangent into 2 over 1 plus tangent, so the logs add to log 2. So I is pi over 8 times log 2. Question 9. Reflect x to 2 minus x. The root moves on a plane x, then two fractional powers. The property converts to 2 minus x times root x. Evaluate the powers at 2. 16 root 2 over 15. Question 10. Expand the double angle log and watch the signs cancel. Log tangent appears, whose integral over the quarter turn is 0. Sine 2x is 2 sine cosine. The combination reduces to log tangent minus log 2. The log tangent integral vanishes by reflection, leaving minus pi over 2 log 2. Question 11. An even integrand on a symmetric interval. Double the right half. Sine squared is even, so the integral doubles over 0 to pi over 2. Pi over 2. Question 12. The king property strips the x from the numerator, then a secant tangent evaluation, reflecting x to pi minus x and adding. 2I is pi times the integral without x, and that integral evaluates to 2 via 1 minus sine over cosine squared. So I equals pi. Question 13. An odd power on a symmetric interval. Instant 0. Sine to the 7th is odd. The two halves cancel exactly. 0, no computation needed. Question 14. A full period of an odd symmetric cosine power. Two properties chain together. Cosine to the 5th satisfies f of 2 pi minus x equals f of x, so the integral is twice that over 0 to pi. But over 0 to pi, the reflection at pi over 2 gives 0. 0 overall. Question 15. The reflection flips the numerator's sign and fixes the denominator, I equals minus I. Swapping x for pi over 2 minus x sends the integrand to its negative. The only number equal to its own negative is 0. Question 16. A grand classic. Reflect, add, and reduce to the log sign integral. The known result minus pi log 2 emerges. Adding I to its reflection gives the log of sine squared, twice the log sine integral, which is known to be minus pi over 2 log 2 on the half interval. So I is minus pi log 2. Question 17. The king template on a general interval 0 to a. Reflect and add. The reflected fraction has root a minus x on top. The sum is 1. Half of a. Question 18. One more modulus split at 1. A small triangle and a large one. Split at the corner. 5. Question 19. An abstract identity. F is symmetric under reflection and G pairs to 4. Reflect the whole product and add. Apply the reflection property to the product and use both given conditions. Add the two expressions for I. The G terms cancel, leaving 4 times the F integral. Question 20, multiple choice. Sort the terms by parity. 3 odd terms and 1 constant. X cubed, x cosine x, and tangent to the 5th are all odd. They vanish on the symmetric interval. Only the one survives, integrating to pi. Option C. Question 21, the final one, multiple choice. The reflection swaps sine and cosine inside the log. The log of a ratio flips sine under the swap. Reflecting gives the reciprocal ratio, whose log is the negative. I equals minus I, so I is 0. Option C. That completes all 21 questions of exercise 7.10. In the next video, we will take up the miscellaneous exercise on Chapter 7, the grand finale of integrals. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.